only for recording.
Okay.
Back if you want.
Can we start? Hi everyone. My name is Michael Golubev. I work for Swiss company Montage. I am kind of committed to the Eclipse Papyrus project, going to be committed very soon. And I'm going to present you the very new thing which is not yet ready, but will be ready in the next release of the Eclipse Papyrus. And this is our best attempt to bring the UML modeling back into the life of ordinary software developers. So, as vendors of the open source UML and SysML tool, we know that in general UML and SysML has huge success. So we know that it is widely used by architects in big design meetings or to specify the big system from big details down to the smaller one. We know that there is a huge success of using that from the code generator. Just today, Eclipse has approved release for the UML generators project from. So we know that there is a huge software system which are generated from their UML representation. It is used for generating the documentation and for tech writers to document something. I know about the usage of the UML in the lawyers, by the lawyers, to just enforce like structure and then enforce some contractual terms of some system. But I think that it is not that much used by real software developers. We think that we understand the reason why that, and we think that right now is very good time to actually address these reasons. So one of the reasons for that is just the complexity. So both UML and SysML are complex standards, and closer you go to the world of the developer, more complex it becomes. So it is more or less easy to specify a structure of some system, but when you want to specify behavior, both standards allow to do that, but complexity of that is huge. Then we think that one of the generic problems comes from the fact that both standards by nature are language agnostic. So there are different ways of mapping simple, trivial Java constructs into the UML, and there are different flaming wars about how to do that better, or so there are no fixed way of representing that in terms which are understandable by just pure human like me. I know that there is a UML profile for Java, but personally I think that maybe it even adds more complexity to the UML. So just using that does not help a lot in real life. And finally, there are two big problems which are for diagrams specifically, and one of them is that the code we work on is normally big, and diagrams don't work well with the big when they are big. So normal size, which is manageable at the diagram, no matter what tool you are using, is something like 20 classes, and 20 classes is nothing in the code development. As a result, diagramming may be used by normal people, like by normal developers, but the process is basically detached from the coding activity. So you do coding activity, you switch to the diagrams, and you do diagramming activity, whatever it may be, and then back and forth. And our goal with Papyrus4J project is bring it back to the laptops of normal, ordinary software developers. So I want to give a quick conceptual overview of how we are going to do that, and then explain why we choose on this way and how this should address the, all the big problems with the diagramming and development in general. So the good news for us is that we already have two excellent projects we need to synchronize. At the left, we have GDT artifacts, a lot of Java code we have. And we have excellent GDT subsystem which handles a lot of stuff for us and provide us with a lot of the things like notifications, structured updates, refactoring, and so on. And at the right, we have Papyrus, which is proven to be a good tool for managing UML models. And what we want is just bring that together. So, in fact, Papyrus does not come for free. I mean, it is free, but it requires, it only works with the UML2 models. So we already have the UML2 model as a representation for which can be shown at the Papyrus diagrams. But fortunately, Papyrus provides us with the synchronization between the two. So whatever is changed at the diagram is pushed to the UML2 model, and whatever is changed in the model automatically updated in the diagram. So the path is now looks like that. So also fortunately, we have some kind of the EMF representation for the Java model already available in the Eclipse. And this is maybe not that famous as Papyrus, but we have a gem project, which is contribution from the IBM, which is now the part of the WebTools project and is already included into the a lot of the, I think it is included in mostly every Eclipse package you have. So what it is? It is basically an EMF-based representation for the GDT, and it comes with some kinds of the synchronization between the GDT and the gem model. So again, we want to get as much as we can for free, and we have this. And so this is the system which is optimized and used for, I think, 5 or 6, maybe even for multiple years in Eclipse production, and we decided that we are going to use it because it allows us to speak into the model-to-model transformation language. So unfortunately, it is not, it does not solve all the possible problems, so we need to extend it. Specifically, it does not provide the good transformation from the model to the GDT. It's basically the way of, after updating representation of the GDT model in terms of EMF. So we need to extend it and provide the purple link to generate something from the gem model to the GDT. This is done by the coded generation, but at the level of every method. So when we need to generate something, we are basically generating only the declaration by just executing small extend coded generators. So now what we have is just to synchronize between two models And there are two, so we were discussing two ways of doing that. So first we started implementation with the QVTO. So just running the QVTO transformation from UML and from GEM. So there are two ways, transformation and separate transformation. And this is a main drawback because we need to write two different things and ensure that they are correctly producing what the other script will produce back when it is executed into other direction. So that's proven to be difficult. That's basically one of the reasons why I am still not showing a live demo. And so we decided to switch that into some kind of operational transformation framework. We will have the new operational transformation framework as part of Papyrus anyway in the Neon, which is AOF, and which allows you to actually write the synchronization code in one place. So this is our way of doing that. But since we're already going to have two implementation like QVTO and AOF based, we decided that it will be pluggable. And so if someone wants to change some pieces or provide its own bridge between two models, it will be possible. And I will explain why it is important. Yeah, so that's basically how we are going to build it. And will try to explain why it is a time and why every piece of this picture actually helps us to solve the gap I was talking in the preamble. So the first thing is about the big, the fact that the code is big and diagrams are small. And here we're leveraging the just added to the capabilities which are just added to Papyrus into the Mars release. And this is basically one of them is the different modes of how Papyrus can now populate and synchronize the diagram with its model. So we will inevitably have a big UML model which comes from big code model. We cannot reduce that. But now Papyrus is very good in managing the diagrams for big semantic models. First, because you can now have quick population of the big diagrams when you want to add something by just switching on. So every container in Papyrus can be made synchronized, and it will automatically add the first time the contents of the model to the diagram and will maintain the synchronization later. This is optional, so it can be switched off. So one of the simplest way of doing that is just to start with something is to synchronize it with contents and then remove what you don't need. And for this removal, there are many ways. So in the non-synchronized mode, you can just, as always in Papyrus, you were able to remove any stuff you like. But now we can have a better from the both worlds. So we can have the diagram synchronized and automatically picking up the new stuff which comes from GDT to GEM, then to UML model. So we have added the method, and it is now in the UML model. And now with this new feature of Papyrus, we can automatically pick it up by the diagram. But still, we can have a diagram set the manageable size because we have CSS support with semantic selectors. So at the picture, I started with what we generated from the ArrayList class. And it is actually huge. So there is 3 times bigger than actual part of the picture. Then I just added selector to the diagram to avoid showing the private properties. and private, and only show the public methods. And then I tweaked that by adding more selectors to by choosing the stuff I actually want to have. So we have bigger control, and that allows us to actually manage the diagrams which comes from the big code now. Also, there is native for Papyrus support for related elements, so you can switch, you can select any element and try to find elements which are related by means of some links and yeah, but by some links, or just show the links which are between different elements. And this also allows to quickly populate the diagram and tweak it into exactly the contents you want to have. Yeah, and finally, while we cannot solve the problem with the semantic model size, we can definitely solve the problem. We can just split we can just use the ability of Papyrus to work with a single semantic model in many different diagrams. So there was a major improvements in the Mars release in this area, and we know that Papyrus can handle huge semantic models, and in Neon release we also probably will have the automatic synchronization between different diagrams, so change from one diagram may be propagated into the other one. Yeah, so so now I'm trying to tell about why and how we're going to battle the problem of the Java agnostic, like language agnostic of the UML. So there are many very trivial Java constructs which don't have like default representation in the UML. So to list a few, I just written the first 5 I was able to mention. So there are no direct relationship between the primitive types. So UML primitive types are not directly related to what we have in the code. There are no objects and no implicit inheritance, and even though there are some strings, there are no such things like normal string methods we always use. There is no different mapping for the annotations, so we cannot, we may argue between each other how exactly to represent the annotation, whether to use profiles and stereotypes and how. Then the simple way, the simple thing like a Java field can be represented either as an association with its association ends, and difficult, like complex UML way of representing the associations, or it may be represented as fields, like we would expect at the normal diagram. And stuff like maps, not even I'm not even speaking about the complexity of representing the templated stuff in the UML, because it is not trivial to just create the UML structure which represents the map, which is bound by something by two classifiers. But we actually don't want to have maps. We probably may want, as with the associations, we want to represent that, may want to represent it as a qualified associations. And again, this is a good time for us to get there, because again, in Mars release, Papyrus started to support many of the things here natively. So for the last three things, Papyrus now allows you to optionally select the way of choosing, the way of representing all the things. You can transform association and show it as property and stuff like that. So it's a good time. But the schema we were thinking about allows, so there was a purple line to have extend code generation for a simple constructs, and that's here where we are going to allow the pluggability for this different representation for the Java elements. So the set of the things we are thinking about, like they mentioned, will be handled by the by the default code generator, and will be allowed to switch to, and developer may choose to how actually to represent that in the code in preferences, since it is pluggable and we will have some kind of open API for that, we expect that many different solutions may find its way to this. Yeah, and to address the problem with detaching the stuff with to address the state where developer is detached from the coding is detached from the diagramming, we are going to introduce the synchronization. So the whole purpose of the synchronization is to have the live diagrams. So any update in the code. So we are mostly, so as a first step, we are targeting the synchronization from code to the diagram. So that's why live diagram. So the changes triggered by the in the editor comes for free for us to the GDT delta, handled by the existing gem extension and transformed into the new UML construct. Then the presence of the UML model as a separate semantic stuff allows us to match the change against, match the new element against the old one, and propagate the change into the diagram. On top of that, we found that it is impossible to handle big updates this way, because you may find very big deltas if you are renaming the class which is used in a lot of classes, and this is quickly goes out of the control. So on top of that, Papyrus4J is participating in the refactoring, so it's registered as a refactoring participant, and it allows to first it provides you with the time, because refactoring is known to be the long operation, and Eclipse provides you with all the needs to be prepared. And also it allows us, instead of just processing the delta, because when you are processing the delta, the old state may be at this time gone, and you are in trouble by trying to match the different things against the state you never have. And it is known to be, it is better to have to participate in the change in advance when it is not yet completed, and plan for the change in advance. So this is a primary priority for the Papyrus4J, and this is what we are actually working on. The lesser priority for us is actually updating the code from the diagram. And I think that at the Neon release, we are only going to be able to do that by means of running the refactorings. So we are participating in the refactorings on the way from GDT to UML, and on the way from UML to GDT, we will initiate these refactorings, because otherwise just renaming at the diagram the class actually requires to running refactoring, and so the system will have some ways of defining the changes that has to be, which are actually renames. So, and for every rename, we will just run the corresponding refactoring, which is provided by the GDT UI, and we already have it. Also, we already have in the prototype the easy navigation between the code and the diagram, because gem models knows about the GDT stuff, and bridge, which is executed between the gem and UML, knows about both of them, and the diagram knows about the UML. So we have easy ways of navigating from code to the diagram and back, except that we always need to avoid the concurrent modifications. So we enforcing just by saving that when you work with the diagram, your code is saved, and when you work with the code, your diagram is saved. So that's our way of ensuring that notification actually may work, and we don't have the collisions. Yeah, and I haven't yet seen that, but in Papyrus, I know that for the CDT and for some other language integration, there is an interesting idea of showing the method bodies inside the property sheet, which should probably allow you to avoid unnecessary switching between the diagrams and the code when you only want to look at how some small piece of code is implemented, and we will just reuse this. So this is already implemented and is already in production for Papyrus4T. So, and it shows the real editor inside the property sheet. So what we need to do is just add the same thing for Java. That's a quick update from me. So the development process has started 2 months ago at the start of the Neon cycle. Before that, there were some prototyping work and work on the QBTO transformation that allows you to execute QBTO transformation interactively, and which we may or may not use in the, at least we are going to use it as a one way of doing the bridge. And so we are planning to be released as part of the Papyrus release in this simultaneous release in June. So stay tuned, and at the early next year, please visit the Papyrus M4 download area and try it with M4. That's it from me. Thank you very much.
I wish. Do you have some questions or some beginning?
So my first question, even referring to the to one of the first slides, you are showing the objects and the classes. But the proper Java programming is not about the classes, it's about interfaces.
Yeah.
How? And how tackle the problem of the multiple interfaces for the objects. So usually these are generic interfaces and they are multiple interfaces, which are plus inheritors.
Yeah, this is typically the things that you can find also in UML. You have the same